From Cape Canaveral in Florida, this is Atlas Launch Control at T-minus 2 hours and holding. We're now just 2.5 hours away from the liftoff of NASA's TDRS-K Tracking and Data Relay Satellite. Launches atop a United Launch Alliance Atlas V rocket from Launch Complex 41 at Cape Canaveral. The launch window today extends from 8:48 to 9:28 p.m. The launch window tonight is 40 minutes in duration. This will be the 35th Atlas V rocket to be launched from Cape Canaveral Air Force Station. The TDRS-K Tracking and Data Relay Satellite will relay voice, data, and telemetry communications between spacecraft in Earth orbit and ground controllers. This includes the International Space Station, the Hubble Space Telescope, and scientific satellites. Even the Atlas rocket being launched tonight with TDRS-K will be tracked using the TDRS system in orbit, taking over from the ground tracking stations of the Eastern Range beginning about 6.5 minutes into the flight. 10 tracking and data relay satellites have been launched since the first one launched on the Space Shuttle on April 4, 1983, almost exactly 30 years ago. The TDRS system allows almost constant space communication. Because of the reliability and longevity of the system, TDRS-K is the first one to be launched by NASA that the agency has needed since 2002, over 10 years ago. The spacecraft was built for NASA by Boeing Space Systems. We had a weather briefing about a half an hour ago, and right now our chance of weather criteria violation remains at about 30%. The main thing that we'll be watching for the start of tanking and for liftoff will be the winds. Our temperature at launch will be approximately 74 degrees with a relative humidity of 80%. And our winds are expected to be generally from the south in the 20 to 24 knot range. So at this time we're awaiting our poll from the NASA Launch Director Tim Dunn of the NASA team, and that will be followed by the poll of the Atlas team to begin tanking of the Atlas V rocket with cryogenic propellants. At T-minus 2 hours and holding with 6 minutes remaining this planned built-in hold, this is Atlas Launch Control.
SRV cycle test complete.
Roger. Pretest briefing. This operation is classified hazardous. Cryogenics will be loaded. Ordnance items are installed, and high pressure and inert gases are in use. Any anomalies will be brought to the attention of the launch conductor. Evaluation will be performed by a support team led by the anomaly chief and the vehicle system engineer on channel 6. COM channel 1 will be primary command channel, with backup being COM channel 2. The following documentation will be in use for today's operation. Test plan X45-LCC-MD-SLC Rev 11 Run 1. Order revisions 003 and 004 have been approved and integrated with the procedure. PSM document configuration AV036 Rev Charlie.
LCAC.
Go ahead.
Roger, I'm prepared to provide you the out brief on the house gas issue.
Roger. NLM?
NLM Channel 1.
LD?
LD on 1.
AC, proceed.
Roger, as reported earlier, we experienced abnormal signatures on the house gas system. Golf Nancy Quebec 032 uniform, which is the the O2 monitor for the ISA vent, reading abnormal. This measurement is used and it is identified within our red line documentation with a not to exceed 1.23% max. Since we will be violating, our recommendation is to disable that particular measurement and using option 329 and disabling the O2 monitoring. This will avoid any nuisance alarms to the operator. Furthermore, we'll use Golf Nancy Quebec 030 uniform, which is the O2 sensor for the LH2 sump pump, as well as the O2 sensor for the prop duct flange, which is Golf Nancy Quebec 034 uniform. These will be manually monitored for the same criteria of 1.23% maximum GOX. So recommendation is to put that in work and to proceed with the operation.
LC concurs. NLM?
NLM concurs.
LD?
LD copies and concurs.
Readiness poll for cryogenic tanking. Atlas systems propulsion.
Ready.
Hydraulics.
Ready.
Pneumatics.
Ready.
Water.
Ready.
Centaur systems propulsion.
Ready.
Pneumatics.
Ready.
LO2.
Ready.
LH2.
Ready.
Has gas.
Ready.
Electrical systems. Airborne.
Ready.
Ground.
Ready.
Facility.
Ready.
RFFTS.
Ready.
Flight control.
Ready.
Instrumentation.
Ready.
COM.
Ready.
Timer.
Ready.
GC cube.
Ready.
Umbilicals.
Ready.
ECS.
Ready.
Redline monitor.
Ready.
Quality.
Ready.
Op safety manager.
Ready.
ULA safety officer.
Ready.
Range and weather.
Ready.
Launch director. Launch director, net 1. Launch director, LC, net 1.
Launch directors on 1.
And looking for your ready to proceed with cryogenic tanking.
Stand by. Need to get go from NASA.
On my mark, T-minus
Timer.
2 hours.
Please do not pick up the count. Extend the hold.
Stand by, LC. We're going through our polls now.
LCCOM, we're counting.
Timer, allow the count to proceed. And we'll stand by.
LC, this LD on channel 1.
Go ahead.
LC, at this time, we have a go to proceed with cryogenic tanking.
Copy. Proceeding with the count. Pressurized Centaur LO2 storage tank to chill down level.
Roger.
Start Atlas LO2 ground chill down.
Roger.
Start Centaur bottle pressurization to flight level.
Roger.
Start Atlas AHB pressurization to flight level.
Roger.
Pressurize Atlas RP1 tank to step 2.
Roger.
Adjust CISA temp to 110 degrees Fahrenheit.
Roger.
Initiate CEC safing purge.
Roger.
Start CEP to high flow.
Roger.
Start CFA purge in displacement mode. Roger.
This is Atlas Launch Control at T-minus 1 hour, 56 minutes, 50 seconds and counting, where we have received a go to move into the cryogenic tanking process of our Atlas V rocket, beginning the chill down process to condition all the lines through which the cryogenic propellants will be flowing. Right now we have joining us Badri Yunus, the Deputy Associate Administrator for Space Communications and Navigation at NASA headquarters. And we've asked Badri to sort of set the stage a bit for us here if you can, because the evolution of spaceflight tracking really goes way, way back and brings us to sort of a very current state-of-the-art, which is completely different technology than what we began with, say, in the Mercury program. So, Badri, we're going to roll this tape, and if you can tell us a little bit about the history and then lead us into TDRS.
Definitely.
Roll the tape.
Are we on the air? Okay. In the 70s, prior to the TDRS, NASA relied on a number of ground stations distributed worldwide, and still, we needed a number of ships and number of airplanes to provide some coverage to our mission, in particular to our human flight missions. Even with that, over 20 some ground station and about five aerial and 5 naval ships, we couldn't provide more than 15% coverage. So the concept for the space network, in particular for the TDRS constellation, came at that time. We needed something that can provide us much better coverage and also get us out of these not so secure places on Earth. Definitely our location on Earth depended to a large extent on the political situation in that country. They could get us out any time. There were certain locations that were not safe, and we had to send our engineers and our operators over there. So it took some time for the concept to evolve into the TDRS constellation and the space network that we know. It started with our launch of the first TDRS in the early 80s, 2003, to be precise. So it has been 20 years, and the space network hasn't stopped to provide the kind of critical support to all of NASA, be that human space flight and other science mission, for anything that orbits the Earth between the surface of the Earth and the geostationary orbit. The support that it provides is extremely critical. It provides, an open kind of continuous data channel between the user in space and the ground, and vice versa.
So at this point, when we look farther out, it would appear, based on the success of the TDRS network, that space-based tracking is really sort of here to stay. And can you kind of look a little bit into the future?
Oh, definitely. The TDRS experience and the space network experience have demonstrated that the services provided by TDRS are unmatched. There are no other systems, and there is no other way. Actually, there are no alternatives to TDRS. The cost is definitely much lower than we would have to pay had there been an alternative, but there are no alternatives. We have looked at other systems, other space systems providing communication support to commercial services, but they could not do what TDRS is doing. TDRS is, designed to support anything in space, while the other systems are designed to support the ground, users. So the market is different. So with this TDRS-K, we are introducing the first of 3 satellites, the 3rd generation tracking and data relay satellite systems. And we are introducing these 3 satellites to replenish the constellation that we have. It has been 10 years since we flew the last, or since we launched the last of the 2nd generation TDRSs. This particular effort has been more than 8 years in the making. Dedicated effort by the SCAN team, in particular by our folks at Goddard Space Flight Center, be that the engineers and the managers and the support personnel there, as well as the entire SCAN team. So really today we are all looking forward to a successful launch. Definitely, the space network is not only important to NASA, it's important to the country as a whole. It's a national asset. It has provided support to other NASA users. We have supported NOAA, NSF, and many other agencies. Again, the kind of capabilities we have are unmatched. The cost is pretty low compared to other means, and it's definitely a very reliable system.
Well, Badri, thank you very much. And of course, we're looking forward to a favorable launch tonight, as I'm sure everyone on the system
Before
is.
leaving the air, it's really rocket science. I'm always impressed by the level of complexity that such an effort takes. But the kind of people that we have in here, from the Boeing, the manufacturer of the satellite, to the ULA folks in here who are responsible for the Atlas V, to working together with our launch service program, as well as the technical folks at Goddard Space Flight Center, who are managing and operating the space network, and they did manage the development activities of the TDRS, has been awesome. We have a very cohesive team. We have a superb team. We really, you look at NASA at its best, where the can-do attitude is prevailing. Hopefully we'll have a successful launch. We are extremely looking forward to its completion.
Badri, thank you very much, and we're looking forward to the liftoff as well. It looks like fueling's underway, so we're on the right track. Thank you very much. We're at T-minus 1 hour, 49 minutes, 33 seconds, and counting. This is Atlas Launch Control.
Payload and CEM ECS have been on GN2 for 40 minutes minimum. Roger.
LC step 1170. If the cycle test complete and if this receiver secured.
Roger. CEC safing purge is active. Roger. And CEP on high flow. Roger.
Centaur LO2 transfer line chill down complete.
Roger. Start Centaur LO2 tanking.
Roger.
This is Atlas Launch Control at T-minus 1 hour, 43 minutes, 18 seconds and counting. Loading of the Centaur stage with liquid oxygen now underway. We'll look briefly at some video of the rollout taken yesterday at about 10 o'clock in the morning of the Atlas V with TDRS-K going to the launch pad. We have an unusually large fairing on top of the Atlas V this time. It's a 14-foot fairing. Our total length of the vehicle there, as we see it, is 192 feet. The RP1 fuel, which is a highly refined kerosene, was loaded aboard yesterday afternoon at around 2 o'clock. And it is holding 25,540 gallons of RP1. The liquid oxygen on the Centaur, which is being loaded on board now, amounts to about 4,150 gallons. Altogether, it took about a half hour to get from the vertical integration facility out to the launch pad at Space Launch Complex 41. Once we lift off, the Atlas first stage will burn for about 4 minutes and 2 seconds before the Centaur stage separates and the Centaur ignites. This is a time-lapse of the Atlas V going out to the pad. So at this point, everything continuing to go well in our countdown. We continue to be on schedule for a liftoff at 8:48 p.m. tonight. At T-minus 1 hour, 40 minutes, 47 seconds and counting, this is Atlas Launch Control.
Centaur LH2 SBV cycle test complete.
Roger. T-minus 1 hour, 40 minutes. LO2 at Centaur LO2 at 10%.
Roger.
This is Atlas Launch Control, T-minus 1 hour, 37 minutes, 35 seconds and counting. We've just received word that the TDRS-K spacecraft is in launch configuration. The next thing to occur for the TDRS spacecraft will be to go to internal, which will be approximately 15 minutes before launch. Next up in our tanking operations will be the liquid oxygen tanking, which will be starting in less than 5 minutes. We should hear our launch conductor give a call for that activity. And shortly after that, we'll begin chilling down the transfer lines for the loading of the liquid hydrogen on board the Centaur. We're now at 20% on the LO2 tanking for the Centaur stage, liquid oxygen. Weather continues to be 30% no-go, so generally the forecast is favorable, and the launch weather officer, Clay Flynn, forecasts a gradual decrease in the wind as darkness sets in and we move into the evening. So we continue to target an 8:48 p.m. liftoff at T-minus 1 hour, 36 minutes, 11 seconds and counting. This is Atlas Launch Control.
LC Flight Control.
Go ahead.
Operation 40, step 1180. Secondary adjust, TechX file, adjust, underscore, alpha, Victor, 036, underscore 04, with STL CRC 47 Delta 9 has been received, verified, and loaded into the FTINU.
Roger.
T-minus 1 hour, 35 minutes.
The CLC performing communication checks on countdown net 1. Respond loud and clear. SMD.
This is SMD. Loud and clear.
NSC.
Loud and clear.
LDD.
Loud and clear.
TD.
Loud and clear.
NLM.
NLM, loud and clear.
This completes comm checks.
Centaur LO2 at 30%.
Roger.
T-minus 1 hour, 33 minutes.
Pressurized Centaur LH2 storage tank to chill down level.
Roger.
Centaur LO2 at 40%.
Roger.
Step 1210, RP1 pressure decay test complete and RP1 tank stable at step 2 pressure.
Roger.
ECB stable at prefill.
Roger.
RD-180 has been on heated GN2 for 20 minutes minimum.
Roger.
Atlas LO2 ground chill down complete.
Roger. Start Atlas LO2 tanking operation.
Roger.
This is Atlas Launch Control, T-minus 1 hour, 30 minutes, 50 seconds and counting. We've heard the start of the loading liquid oxygen onto the Atlas stage. And the next milestone in just about 3 or 4 minutes will be to start the chill down process in preparation for loading liquid hydrogen onto the Centaur. It's a rather long flight tonight. Spacecraft separation won't occur until 1 hour and 46 minutes after launch. That means there'll be a fairly lengthy coast phase after the liftoff. The coast will start approximately 18 minutes after the cutoff of the Centaur. And at that point, the coast phase duration will be about 1 hour and 22 minutes. And then the Centaur will restart 1 hour and 40 minutes into the flight. During the coast phase, the vehicle will be in a highly elliptical orbit of 113.2 by 13,402 miles until spacecraft separation, when the rocket and the spacecraft will be somewhat higher than that, placing it into its initial planned transfer orbit. And we're about 50% on the liquid oxygen on board the Atlas. We're at T-minus 1 hour, 28 minutes, 56 seconds and counting. This is Atlas Launch Control.
Centaur LO2 at 60%.
Roger.
LCALO.
Go ahead.
Yes, LC at the start of LOX tanking, both booster fill and drain valve open indicators failed to respond. The instructions in the procedure requires us to initiate an anomaly discussion at this point.
Roger. ACLC,
ACM1.
please convene the anomaly team and provide a recommendation for the booster fill and drain valve open anomaly.
Anomaly team to channel 6.
Centaur LO2 at 70%.
Roger.
T-minus 1 hour, 25 minutes.
Centaur bottles at flight mass, step 1250.
Roger.
Centaur.
This is Atlas Launch Control, T-minus 1 hour, 23 minutes, 53 seconds and counting. 75% of liquid oxygen on board the Atlas stage, as we just heard. And joining us now here at the Public Affairs Console in the Atlas Launch Control Center is Jeff Gramling. He is the project manager for TDRS-K, and Jeff, would like to welcome you very much, and hopefully you've had an uneventful countdown up to this point. Is the spacecraft exactly where it should be at this point in the count?
Yes, George, we're all very happy. Everything so far is looking very good. We haven't seen any problems, and we're ready to launch tonight.
Well, we've got some video of what your processing flow looked like from when you arrived right up to going up out to meet the Atlas Atlas V. So if we could roll the tape, and Jeffrey, if you could tell us what we're seeing.
Sure. Well, what you see here, George, is we flew in a C-17 from the Boeing plant in El Segundo, California, from Los Angeles International to the shuttle landing strip on Kennedy Space Center. And what you see here is the payload container being offloaded from the C-17, and from the shuttle landing strip it was transported over to Astrotech in Titusville, where we did spacecraft processing for a few weeks.
And the spacecraft came in from where?
The Boeing facility in El Segundo, California. So the C-17 actually took off right across the street from the plant from Los Angeles Air Force Base, and then flew to Kennedy. And you see it's a rather large container. Of course, the spacecraft in that container is in the horizontal position with everything stowed as it would be in the payload fairing for launch. And here you can see it arriving at the Astrotech facility in Titusville. And that's a very large high bay, so we can do our spacecraft processing that has to happen before we encapsulate in the Atlas fairing, which you'll see coming up here.
Altogether, the total amount of time you were out at Astrotech from the time you arrived until rollout was about how long?
Well, we landed at Kennedy on December 18th, and then because of the holidays, we did some testing before the holidays, and then we stood down for a week or so, and then we left Astrotech a week and a half ago, so we were there for 2 or 3 weeks. And you can see here the container being opened up, and there you see the spacecraft bagged for shipping. And you can see the single access antenna reflectors sticking out of the bag there. And here's the technicians unbagging the spacecraft to protect it during shipping. And what you see here is it being placed on a test fixture in one of the high bays at Astrotech.
So then there's a series of electrical tests, I gather, before you start to fuel.
Right, several electrical tests to make sure that the spacecraft is functional. We do the tests that we can do. Obviously, we can't do all of the testing that we could have done in the Boeing plant in El Segundo, but we do enough to make us comfortable the spacecraft has survived shipment and we're ready to launch. So here you can see the spacecraft is still basically in the launch configuration with the single axis reflectors stowed, or in this case they're furled around one another. With solar wings folded there against the body on two sides with the outer panel exposed so that in transfer orbit as we're spinning we can get power. And what you see here are the two halves of the Atlas fairing being maneuvered around the spacecraft. And you can see, George, here that the TDRS spacecraft does a pretty good job of filling that extended Atlas fairing that we use. And at this point, we're encapsulated, and what you'll see coming up is the spacecraft being and the fairing placed on a truck and being driven over to the vertical integration facility on Launch Complex 41, and that happened at about 2 in the morning a week and a half ago.
So once you get out to the pad, then you're ready to mate to the rocket and get ready to fly.
Right. So once we got out to the pad, obviously, then in the vertical integration facility, we were lifted up and stacked on top of the Atlas Centaur. And of course, the picture you're seeing right now is after we've rolled out to the pad. Obviously, that was yesterday morning. I think this must be a current picture here. It's in the evening.
Now tell us a little bit after the spacecraft comes off the rocket later tonight. What are the things that are going to happen right away, and what are the things that will happen a little bit later on? What are the milestones?
So right after we launch, an hour and 40 minutes or so after that, we'll actually separate from the Centaur upper stage, and after that we should be seeing telemetry signal from the satellite through the USN tracking network. Some period of time later, I think it's on the order of an hour or so, a couple hours maybe, the only deployment we do before we get to GEO is we unfurl the single axis reflectors, and then it takes about 10 days for us to get from our geosynchronous transfer orbit that the Centaur leaves us in until we use an internal engine to get up to our geosynchronous altitude. In other words, we've circularized our orbit. That whole period is controlled out of the Boeing Mission Control Center in El Segundo, California. Once we get to GEO, we would finish all of our deployments, unfurl the solar wings, deploy the single-axis antenna booms, and once we've done that, then we would hand over to the White Sands ground station in New Mexico, which is our ground station, and from there on we'd undergo about 3 months of calibration and on-orbit testing before we would drift the spacecraft to its operational location.
And again, it's about how many days after launch until you're up actually at the geosynchronous altitude?
It's about 10 days.
About 10 days. Okay. All right. So at that point, you'll be doing the checkout, and when that's complete after 3 months or so, where will the spacecraft move to, or will it stay pretty much where it's at?
When we launch, we go to 149.8, I believe it is, west longitude. Once we're finished on orbit checkout and testing, then I believe the plan is to drift it to 171 degrees west, where we would continue testing with more users that are actually flying to gain confidence, and then a decision will be made, whether to keep it in service or to put it in the storage, depending on the health of the other spacecraft in the fleet.
All right. Well, are you actually working the next TDRS spacecraft coming up in a year or so?
Yeah, I am. My project is in this is the first one. We started this about 6 years ago. TDRS-K we're launching today. TDRS-L will be going into storage. We'll finish testing here in a couple months. It will go into storage, and right now the plan is to launch next January. So we'll be back here in a year, and we're looking forward to that. And then TDRS-M will be ready to launch in December of 2015. So we've got our hands full. In parallel with this launch activity, we're also completing testing of TDRS-L on the high bay back at Boeing.
Well, Jeffrey, thanks very much, and best of luck to you and the Goddard team as well as the Boeing team, and we'll look forward to seeing this in its initial orbit later tonight.
Okay, thank you, George.
Thank you very much. We're now at T-minus 1 hour, 14 minutes, 49 seconds, and counting. This is Atlas Launch Control.
TLO2 at flight level.
Roger.
LDN 1.
In Alamo, Channel 1.
LCAC.
Go ahead.
Roger, I am prepared to provide you now brief regarding the issue that was reported by booster locks on the Atlas LOX film drain valve.
Proceed.
Roger, as reported earlier, we have two film drain valve indicators that did not provide a proper close indication. That's Michael Brava Lima 505 and 525 X-ray. These are sense switch indicators that did not provide an open indication when commanded. We did get proper response based on a pressure response in the cavity vent. Based on a pre-canned set of requirements in the redline document under section 1.1.5 Atlas Prop System item 11C, it does call for the disabling of those sensors using option 536 and using the virtual indicator, which is the cavity vent pressure, and proceeding with the count. No additional action is required since those measurements have already been disabled. So recommendation from the team is to proceed and use the virtual indicator for indication.
LC concurs. NLM?
NLM copies and concurs.
LD?
LD copies and concurs.
CFA purge has been in displacement mode for 45 minutes. Roger.
-1 hour, 10 minutes.
Start CFA purge to control mode. Roger.
This is Atlas Launch Control at T-minus 1 hour, 9 minutes, 30 seconds and counting. Joining us now is Diana Calero. She is the Mission Manager for the Launch Services Program here at Kennedy Space Center for the TDRS-K mission. Diana, welcome, and we would really like, if you would, we've got a video of the entire processing of our Atlas V. It includes going up on top of the rocket, and if you could tell us a little bit about what we're seeing as we go along.
Sure, no problem, George. Right now we're seeing the Antonov aircraft landing at the Cape here with the Atlas V booster, and that arrived in on November 5th, and it was transported from Decatur, Alabama, where it's manufactured. And you can see them offloading the booster here. Booster's about 106.5 inches long, 106.5 feet long, and 12.5 feet in diameter. And you see that being covered there. It's really an incredible sight to see how long and how big that booster is. So it's getting loaded onto a transporter. And right now it's making its way to the Atlas Spaceflight Operations Center, or ASOC, where it's going to go through its receiving inspections and go on to some initial power-on checks before it begins to get mated to the other parts of the rocket. So once out of the ASOC, it's transported out to the Vertical Integration Facility, or VIF. And there you'll see they start placing it into a vertical position, and it'll begin its hoist up into the VIF. And the VIF is about 280 feet tall. It's quite large, and this is a 401 vehicle, so it's not their largest vehicle. So there's plenty of room there, and once it's placed on the mobile launch platform, as you can see there inside the VIF, it's going to await the other parts of the vehicle to get mated. After the booster is mated there, the interstage adapter will be mounted on top. There's a good shot of the RD Amros RD-180 engines. Those engines are capable of a thrust of 160,000 pounds and about a specific impulse of 335 seconds. And what we're seeing here now is the Mariner ship that is carrying the Centaur. And the Centaur also is coming from Decatur, where it's assembled, and that has a journey through the different rivers. Starts in the Tennessee River, goes to Ohio, and then the Mississippi River, and then comes out the Gulf and around the peninsula and docks here in Port Canaveral. That gets offloaded and transported also to the ASOC, where it does its receiving and checks, initial checks. And once that's ready, it is transported to the VIF and will also be mated to the top of the booster. And what you'll see now is they're placing in a vertical position in preparation for the hoist. You could see the engine on the Centaur's Pratt & Whitney Rocketdyne RL-10A engine, and that has about a thrust of 22,000 pounds with the specific impulse of 442 seconds. The Centaur is about 41.5 feet long with a 10-foot diameter, and this Centaur was mounted to the booster. It was mated to the booster on January 5th. And once that gets mounted on there, they start doing some initial checks of the vehicle once the vehicle is actually considered completely assembled, just waiting for the spacecraft. And I'll do a combined systems test to make sure that everything is working properly. And you'll see there's a good shot of the engine going into the interstage adapter, which protects the engine once it's mounted. And so now we're just waiting here for the encapsulated spacecraft. There's a nice view of the hand-painted logo on the payload fairing. And so this gets transported in the middle of the night. It's about a 25-mile journey from the Astrotech processing facility. And it gets hoisted and mated on top of the Centaur. And that mate happened on the 19th of January, and there you see the whole rocket being ready for a launch.
Well, Diana, tell us a little bit your role as the mission manager for Launch Services Program. What is your role with the spacecraft, and when did you become involved with TDRS-K?
Well, LSP actually gets involved with the spacecraft about 3 or 4 years ahead, and you start planning for all the requirements they're going to need to interface with the rocket. And so you make your initial requirements and you gather them in preparation to acquire a launch service. And that's where we step in and we acquire that launch service, and in this case it was the ULA Atlas V. And so that happened about in 2008. I actually got involved with TDRS-K about a year ago when I inherited the mission from a former mission manager. So I've been involved with TDRS-K NL for about a year now. So
are you also working the next TDRS coming up in about a year or so, TDRS-L?
Yes, I am, yeah.
So, so just like Jeff Gramley, you're rolling right out of one and into the next one, even though it's a year away.
Yeah, there's not much pause in between the two missions, so we finish off one and we're going into some operations on L already. So,
well, Diana, thank you very much for coming by and showing us what we did to get the Atlas built up out of the pad and ready to fly tonight. And best of luck to you and the rest of the Launch Services Program team.
Thank you very much, George.
And we've gotten to go for the chill down for the cryogenic liquid hydrogen that will be flowing into the Centaur stage a little bit later on. We're at T-minus 1 hour, 2 minutes, 10 seconds and counting. This is Atlas Launch Control.
LCALO.
Go ahead.
Atlas LO2 airborne chill down and slow fill complete. Fast fill started.
Roger. And for all personnel on net 1, I'm showing steps complete through 1310.
T-minus 1 hour.
LH2 chill down complete.
Roger. Start LH2 tanking.
Roger.
Adjust CEM ECS temperature per TRD. Roger.
Atlas LO2 at 10%.
Roger.
step 1320, AHB's at flight mass.
Roger.
T-minus 55 minutes.
Start flight control, final preps.
Roger.
Atlas LO2 at 20%.
Roger.
This is Atlas Launch Control, T-minus 53 minutes, 24 seconds and counting. Our countdown is proceeding through the steps. We're hearing our United Launch Alliance launch conductor Ed Kidda directing his launch team. Upon liftoff, the tracking of the Atlas V rocket will be done by the Air Force Eastern Range, beginning with the antennas at Cape Canaveral Air Force Station and the Kennedy Space Center. 24 seconds after liftoff, the downrange station near Jupiter Inlet in South Florida will also acquire the rocket. The next station to acquire will be at the island of Antigua in the Caribbean, which will take over immediately prior to loss of signal from Florida. Antigua will supply data until approximately 14 minutes into the flight, at which time data will be coming through the TDRS-East tracking and data relay satellite. As the rocket approaches the Indian Ocean, the Air Force tracking stations at Diego Garcia and Guam will also begin covering, right through the spacecraft separation event, which occurs 1 hour 46 minutes after launch. Then once TDRS-K is on its own, having separated from the Atlas V, the initial contact with it will be made through the Dangara tracking station on the coast of Western Australia. At liftoff, if you're following the rocket from the coast and you're wondering what direction it will move, the launch azimuth is 101.4 degrees, just slightly to the south of east. At separation, the orbit of the spacecraft will be an elliptical one, 19,323 miles by 2,328 miles. And as we heard from Jeff Gramling, the spacecraft over the next 10 days will go all the way up to geosynchronous orbit. And we're at 20% now, 20% level on the Atlas first stage liquid oxygen. Weather continues to be green for a launch tonight. And anything we're behind in the countdown with a couple of anomaly discussions that we've had will easily be made up in the hold, which occurs at 7 o'clock tonight. It will be a be a 25-minute hold. The clock will go down to T-minus 4 minutes, hold for 25 minutes, and anything still undone that needs to be finished to catch up to resume the count on time at T-minus 4 minutes will be done during that time. We're now at 30% liquid oxygen on the Atlas vehicle. And Centaur LH2 now at 30%. At T-minus 50 minutes and counting, this is Atlas Launch Control.
Centaur LH2 at 40%.
Roger.
Centaur LH2 at 50%.
Roger.
Atlas LO2 at 40%.
Roger.
Centaur LH2 at 60%.
Roger.
Centaur LH2 at 70%.
Roger.
T-minus 43 minutes.
Centaur LH2 at 80%.
Roger.
Atlas 42 minutes.
Atlas LO2 at 50%.
Roger.
Centaur LH2 at 90%.
Roger.
T-minus 40 minutes.
Start final open loop FTS test.
Roger.
Centaur LH2 at 97%. Topping started.
Roger. Perform Centaur LH2 fill and drain valve cycle test. Roger. Perform Centaur LO2 fill and drain valve cycle test.
Roger.
Atlas LO2 at 60%.
Roger. Initiate BRC ECS.
Roger.
Centaur LH2 fill and drain valve cycle test complete.
Centaur LO2 fill and drain valve cycle test is complete.
Perform Centaur SRV and LH2 SVV cycle tests. Roger. Centaur SRV and LH2 SVV cycle tests complete. Roger. Resume Centaur LH2 topping to flight level.
Roger.
Resume Centaur LO2 topping to flight level.
T-minus 35 minutes. CLO2 at flight level.
Roger.
Atlas LO2 at 70%.
Roger.
T-minus 32 minutes. Minus 31 minutes.
Atlas LO2 at 80%.
Roger. Pressurize ECB to flight pressure.
Roger.
LC, step 1550. FTS input test is complete.
Roger.
This is Atlas Launch Control, T-minus 26 minutes 20 seconds and counting. Loading of propellant aboard the Atlas V rocket continues to go smoothly. We will be continuing in the countdown to T-minus 4 minutes, at which point we'll be entering a 25-minute planned built-in hold, which will allow for any catch-up activities that need to be done. We'll also be getting a weather briefing from our Launch Weather Officer Clay Flynn from the 45th Weather Squadron in about 20 minutes from now. Once we come close to releasing the built-in hold at T-minus 4, we'll get a final poll for the NASA launch team from our NASA launch director Tim Dunn, and then the launch director for United Launch Alliance, Ed Kidder, will be polling his team in preparation for continuing the count and picking up for the last 4 minutes. And at this point, we're still targeting an 8:48 p.m. liftoff. At T-minus 25 minutes, 3 seconds and counting, this is Atlas Launch Control.
T-minus 25 minutes.
Outlets LO2 at 90%.
Roger.
Atlas LO2 at 97.5%. Topping started.
Roger. Perform BRCU, SIB1, and SIB2 voltage checks.
Roger.
Minus 19 minutes.
Perform RD-180 transducer converter calibration.
Roger.
BRCU SIB1 and SIB2 voltage checks are complete.
Roger.
Minus 18 minutes.
RD-180 transducer converter calibration complete.
Roger.
Atlas LO2 at 99.6%.
Roger. Cycle Atlas LO2 fill and drain valve.
Roger.
Perform Atlas Airborne LO2 vent valve functional test.
Roger.
Minus 17 minutes.
Engine fuel inlet valve is closed.
Roger.
Minus 16 minutes.
Initiate fuel fill sequence.
Roger.
LD's on 1.
NLM on channel 1.
Minus 15 minutes.
LCAC?
Go ahead.
Roger, I am prepared to provide you with the avionics decoupler retract pressure anomaly.
Proceed.
Roger, as reported earlier, we've seen a couple of noise excursions on Mike Lima Lima 643 Papa. This is a triple redundant system. The other two measurements, Mike Lima Lima 683 and 663 Papa, are responding correctly. The recommendation from the team is to disable Mike Lima Lima 643 Papa within the red line file. Those would be line items 532, 533, and 534. No additional action is required since the other two measurements are working correctly.
NLC copies and concurs. NLM?
NLM copies and concurs.
LD?
LD copies and concurs.
Redline monitor, LC?
Go ahead.
At this time, are you ready to disable line items 532, 533, and 534?
Roger, LC, I'll put it in work.
Copy.
LC, flight control.
Go ahead.
Operation 40, step 1540. Flight control final preps are complete.
Roger.
LC, redline monitor.
Go ahead.
Line items 532, 533, and 534 have been disabled in redline monitor.
Roger.
This is Atlas Launch Control, T-minus 9 minutes, 7 seconds and counting. The next major event will be a weather briefing by our Launch Weather Officer Clay Flynn, which will occur at T-minus 5 minutes. Also, about a minute later, we should be going into our final planned built-in hold. It's a 25-minute hold at T-minus 4 minutes. And after we go into that hold, we'll have Vernon Thorpe from United Launch Alliance come over and go through the flight sequence of what the Atlas V rocket will be doing as it after it lifts off from the pad. At T-minus 8 minutes and counting, this is Atlas Launch Control.
Comes to RF link. Roger.
Elsie, flight control.
Go ahead.
Operation 40, step 1680. Primary adjust, TechX file, adjust, underscore, Alpha Victor 036 underscore 05 with SELCRC 28 Echo 0 has been received, verified, and is ready to load into the FTINU.
Proceed with load.
Minus 6 minutes. Fuel fill sequence is complete.
Roger.
LCALO.
Go ahead.
Atlas fill and drain valve cycle test is complete.
Roger.
Atlas Airborne Vet Valve Functional Test complete.
Roger. Perform pogo suppressor charge.
Roger.
GCQ, flight control.
Net 1. Weather briefing on Channel 8 Weather Conference Net.
Roger. LWO, range coordinator, Channel 8.
LWO.
Can you stand by for weather brief, please?
Standing by.
Following personnel acknowledge standing by for the weather brief. LD.
LD.
NLM.
NLM.
AFLD. ALC.
ALC.
LWO, please proceed with the weather brief.
Yes, sir. This is the LWO on Channel 8 Weather Briefing CC Local. Taking a look at the peninsula of Florida there, you can see just very limited cloud cover over the Central Florida Peninsula. Not looking for any issues with any type of cumulus cloud, rain showers, thunderstorms. We're in favorable weather conditions for the balance of the county and window. And looking at the radar, nothing on the radar. Not expecting to see anything on the radar for the balance of the county and window. This is the 1-minute data. Peak winds presently just gusting to 21 knots. We've had as high as 24 and a couple of hits to 24 knots. And we should stay in that range, gusting between 20 to 24 knots through the balance of the county and the window. And generally speaking, in terms of the direction, staying from the south, becoming a little more from 190, presently from about 183 to 186. So a little about 190 for the during the window, I believe. And temperature at the present time is 72 and should drop a degree or two. In terms of the upper air profile, taking a look at, the upper air profile. Winds have increased through the count in this region right in here, and would expect to see a continued gradual increase if we were as we progress through the count and window for the balance of the count and window, approximately 5 to 10 knots. In terms of the ops forecast, looking for favorable conditions with just scattered low and scattered high clouds, 7 miles visibility. Winds from the south at 20, gusting 24, no weather, and temperature in the low 70s with a 10% chance of violation. All LCCs are go and expected to remain go. No change in the 24-hour delay forecast. Proton flux remains at normal background levels, and not expecting any lightning, and looking for just gusts to peak gusts to 24 knots to the balance of the count and window. A small threat of exceeding 25 knots and a smaller threat of exceeding 27 knots. This concludes the weather brief. Pending your questions, sir.
Range coordinator has no questions.
LD has no questions.
FLD, no questions. LWO, this is NLM. Do you have the exposure forecast for the morning?
Yes, sir, I do. I apologize. A 10% chance of lightning during the overnight hours, sir. And with that, just with the stronger gradient, if we did get a lightning, I had winds a little elevated for a 38-knot concern if we did get any lightning overnight, sir.
NLM copies, no questions.
This is Atlas Launch Control, T-minus 4 minutes and holding. During the weather briefing, we went into our planned hold at T-minus 4, which is 25 minutes in duration, and we completed the liquid hydrogen loading on board the vehicle. So at this time, we continue with that favorable weather forecast to press on toward an 8:48 p.m. liftoff. At T-minus 4 minutes and holding, this is Atlas Launch Control.
OSM, LC?
OSM.
Verify the FCO, RCO, and OSM hold fire switches are in the proceed position.
Ready to proceed.
This is Atlas Launch Control, T-minus 4 minutes and holding. We're in the middle of a planned 25-minute built-in hold. And we have joining us right now Vern Thorpe from United Launch Alliance. He's the program manager from ULA for NASA missions. Vern, first of all, tell us a little bit how this countdown has been going. It seems like there's been some things that we've had to work, but they all seem to have kind of come out in the wash.
Yeah, we've had a few minor issues. The vehicle's looking healthy, and the weather is cooperating right now. We were a little bit concerned about winds earlier in the count, as you know, but the winds have come down. And we've had a few minor issues on the vehicle, but they've really been in the area of instrumentation type issues. Nothing that would prevent us from launching. So hopefully that will continue.
Well, Vern, we've got some video now that shows us what the Atlas will be doing after liftoff. So If we could go ahead and roll the video, and Vern, tell us what we're seeing.
Okay. This is what the vehicle looks like on the pad tonight. This is an Atlas V 401 configuration. This is footage from a recent launch. At liftoff, the booster engines will be putting out about 900,000 pounds of thrust to get the vehicle off the ground. And since we have no solid rocket boosters on this mission, the first major event that we'll see will happen about 4 minutes into flight. At that point, we will have used up all the propellants in the booster stage, and at that point we will shut down the booster engine. You'll see that here momentarily. And about 6 seconds after we shut down that booster engine, we will send the separation command to separate the booster from the Centaur upper stage. We will then prepare the Centaur engines for the first of 2 burns for this mission. That first burn will last about 14 minutes, and 10 seconds into that first burn, we'll be up out of the atmosphere and we'll jettison the payload fairing, as you saw right there. This 14-minute burn will put us into a highly elliptical orbit. We'll have a perigee of only about 99 nautical miles, but the apogee at that point will be over 13,000 nautical miles. Following that first burn, we'll coast for about 82 minutes. That puts us in position for the second burn that you see right here. That second burn will only last about 1 minute, and that will put us into what we call a geosynchronous transfer orbit. The apogee of that orbit will be up at geosynchronous altitude, which is where the spacecraft will do a series of burns to circularize. After we separate from the spacecraft after that second burn, we'll do a series of maneuvers with the Centaur upper stage to put it into a safe orbit and make sure that there's no possibility of recontact or contamination of the spacecraft.
And then actually what ULA does after the spacecraft is actually on its way, you continue to follow it for some other activities, am I right?
Well, we do a series of maneuvers with the Centaur upper stage, and again, that's to preclude any chance of contaminating or recontacting the spacecraft. Eventually, we'll put it into what's called a safe orbit. It's an orbit that is out of the way, doesn't stand any chance of interfering with the space station or with any other satellites that are up there.
That's where I was going with that question. We're kind of putting it into a safe
yes,
configuration.
The lowest part of that orbit will be above the space station altitude, and it'll be well below the geosynchronous altitude where most of the communication satellites are, and then it'll remain there indefinitely.
Well, Vern, thanks very much, and I guess we're very shortly going to be on the way here, so we will be watching as we get to T0. Everything appears to be on track. The weather looks good, so it looks like TDRS-K may be out of here very shortly.
Okay.
Thank
you,
you very
George.
much for coming by.
My pleasure.
Vern Thorpe, the Program Manager for NASA Missions from United Launch Alliance. At T-minus 4 minutes and holding, this is Atlas Launch Control.
Flight control, Elsie.
Go ahead.
Perform launch on time verification.
Roger. Launch on time verified.
Roger.
This is Atlas Launch Control, T-minus 4 minutes and holding. 12 minutes, 23 seconds remaining in this planned built-in hold. Once liftoff occurs, we'll hear the voice of Marty Malinowski from United Launch Alliance. He's our telemetry engineer for the flight. We'll hear him making all of the calls as the Atlas V goes through its various stages initially into the coast phase, and then for the final burn of the Centaur and spacecraft separation. One point of note is that we do have a collision avoidance quotient on the second minute of our window. So right now we are targeting the opening of the window at 8:48, but we would have a cutout there of a minute at 8:49 and then could pick up again at 8:50 should we not get off right at the opening as we're targeting. But as we've just heard, everything is on time right now for an 8:48 p.m. liftoff. At T-minus 4 minutes and holding, this is Atlas Launch Control.
NSC, LC.
This is NSC.
Spacecraft to internal power.
Roger.
LC switch to ready position. All steps complete prior to the status check. Attention all stations, this is the NLM on the NLM net. We are in good configuration with the launch vehicle. Centaur prop loading is complete. Booster LO2 loading is complete. The range is green. Weather is acceptable at this time. I would now like to conduct the final launch readiness and spacecraft configured for launch poll. NASA CE.
NASA CE, go.
SMA.
SMA's go.
SMD.
SMD's go.
NASA MEM.
NASA MEM is go.
NAM.
NAM's ready.
NLM copies. The NASA team is ready for TDRS-K launch.
LCRC-1.
Go.
Launch window management plan 0228 Zulu.
Copy.
This is Atlas Launch Control. We have about 4 minutes remaining in this planned built-in hold, and we're at T-minus 4 minutes and holding. Momentarily, we should get a final pole to come out of the hold and continue toward on-time liftoff at 8:48. At T-minus 4 minutes and holding, this is Atlas Launch Control.
Status check to proceed with terminal count. Atlas systems, propulsion, go. Hydraulics, go. Pneumatics,
Go.
LO2,
Go.
water.
Go.
Centaur systems, propulsion, go. Pneumatics, go. LO2,
Go.
LH2,
Go.
PAS gas,
Go.
electrical systems, airborne,
Go.
ground,
Go.
facility,
Go.
RFFTS,
Go.
flight control,
Go.
instrumentation,
Go.
comm,
Go.
timer,
Go.
GC cube,
Go.
umbilicals,
Go.
ECS,
Go.
redline monitor,
Go.
quality,
Go.
ops safety manager,
Go.
ULA safety officer,
Go.
range weather and clear to proceed,
Go.
launch director,
LC, you have permission to launch.
proceeding with the count. T0 is planned for 01:48:00. Set count to start at 01:44:00.
Roger. T0 is set for 0148 Zulu. Count will start at 0144.
LC, this is NSC on countdown 1.
Go ahead.
Spacecraft on internal power.
Roger. NSC, LC,
This is NSC.
just verifying spacecraft on internal power.
That is correct, on internal power.
Roger.
This is Atlas Launch Control, T-minus 4 minutes and holding. 1 minute remaining in this hold. TDRS-K is configured for launch. Very quiet here in the Launch Control Center. We're working no issues. "30 seconds to picking up the count. Picking up in 10.
On my mark, time will be T-minus 4 minutes and counting. 3, 2, 1, mark. T-minus 4 minutes and counting.
Ground power is enable.
Final Atlas and Centaur go for launch will be at T-minus 25 seconds. And we'll have engine ignition at T-minus 2.7 seconds.
Minus 315. Minus 3 minutes.
Securing LO2 topping.
Atlas tanks to flight pressure.
Minus 250.
FTS internal.
Minus 2 minutes.
Vehicle internal.
155.
Launch sequencer start.
150.
Securing Centaur LH2.
Securing Centaur LO2.
140.
FCS launch enable.
FTS armed.
$120.
Orca's armed.
FCS count started.
115. 110.
Vent valves locked.
Minus 1 minute.
Rock, report range status.
Range green. Minus 40.
Stable at step 3.
Minus 25.
Status check.
Go Atlas.
Minus
Centaur. Go TDRS-K.
T-minus 15 seconds. T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. And liftoff of the Atlas V rocket with TDRS-K, broadening, enhancing, and improving the capability of space-based tracking.
Roll program has begun. Body rates look good. Bus and battery voltages are stable. Booster engine continues to operate well. Pump speeds are within parameters. Boost pump pressures are good. Currently accelerated at 1.4 Gs. Engine operation continues to be excellent. Roll program's complete. Booster PU is now operating in closed loop control. Lock 1. Max Q. Body rates continue to look very good. Booster has throttled back right on schedule. Engine response looks good. Currently accelerating at 1.8 Gs. Current altitude is 13 miles, downrange distance 9.6 miles. Current velocity is 2,390 miles per hour. Booster performance continues to look very good. This phase in flight. Bus and battery voltages are stable. Tank pressures look good. And closed loop steering has been enabled. Small perturbance in body rates, but everything looks very good. Range track right now looks like they're heading right down the middle of the range. And the RCS pyro valve has been fired. That system's now pressurizing up the flight levels. Signatures look good. Booster performance continues to be nominal. And we have ended the Q alpha limited steering. Body rates are good. Bus and battery voltages are stable. Tank pressures are within parameters. Booster engine performance continues to be nominal. Currently accelerating at 4.4 Gs. All systems look very good. And boost phase chill down is underway. Coming up on our 5G throttle segment. We're now throttling to maintain 5 Gs. And now have throttle back to 4.6 Gs. Boost phase cooldown is complete. And we have BECO. Engine shutdown looks good. We have retros and stage separation. We have LOX and fuel pre-start on the Centaur main engine. The RCS GN2 purge firing is underway. We have ignition on RL10 and full thrust. We have payload fairing jettison. Looks like a clean separation. Range track continues to look very good. Current altitude is 96 miles, downrange distance 299 miles, current velocity 11,142 miles per hour. This burn is expected to be just short of 14 minutes in length. Currently, Centaur is commanding the PU to the oxidizer-rich condition as planned for the early portion of this burn. Centaur closed loop steering has been enabled. Propellant tanks have been vented down to the correct levels for this portion of the burn. Current altitude is 108 miles, downrange distance 445 miles, current velocity 11,354 miles per hour. Vehicle body rates look good. And the range track shows Centaur making good headway right down the middle of the range. Centaur PU is now beginning to control off the oxidizer-rich stop. Quick check of the booster performance shows that we were positive 64 pounds in PE, which is 0.65 sigma in performance. We've begun seeing our RCS thermal conditioning firings. Those line temperatures are now warming towards bottle temperature. Our L10 engine performance continues to look good for the mixture issue that is set. And we have had the format change at this point, just a minor dropout in data. Data quality is currently very good. Bus and battery voltages on Centaur are nominal. Current altitude is 148 miles. Downrange distance is 785 miles. Current velocity is 12,041 miles per hour.
And we've had acquisition
Centaur
through
PU continues to
anticipating losing the signal from the Cape.
Centaur body rates look good, controlling right down the middle. Range track continues to show good progress towards the head-on gate. Centaur currently is flying at 161 nautical miles in altitude, downrange distance of 1,012 miles. Current velocity is 12,644 miles per hour. And Centaur has passed the head-on gate at this point in the mission. Centaur engine performance continues to look very good. Centaur PU continues to operate slightly oxidizer rich. Turbine inlet temperature looks appropriate for the set mixture ratio. RCS line temperatures have nearly warmed to bottle temperature and continue to see our thermal conditioning firings. Signatures look good. Bus and battery voltages are stable. At this point in the mission, Centaur is currently flying at 190 miles in altitude. Downrange distance is 1,442 miles. Current velocity, 13,945 miles. All systems continue to operate nominally at this point in the mission. And Centaur is currently accelerating at 0.56 Gs, as the PU system is now operating near nominal mixed ratios, having burned off the excess oxidizer.
11 minutes, 30 seconds into the mission. We'll have data from Antigua until L plus 14 minutes, 15 seconds, at which point the handoff to TDRS East will occur.
Centaur tank pressures continue to look good. Storage bottle pressures are stable. Bus and battery voltages are within expected range. Continue to see our RCS thermal conditioning firings on a regular basis. That system is now operating at nominal temperatures throughout. And the main engine PU setting is basically nominal. Current altitude is 171 miles, downrange position 1,955 miles, velocity 15,700 miles per hour. Yep. 5 minutes remaining in this mission. Shows Centaur continuing to make good progress right down the middle of the corridor. Current altitude 160 miles, downrange position 2,161 miles, current velocity 16,466 miles per hour. All Centaur systems are within expected parameters. Engine performance continues to look very good.
Losing our signal now through Antigua. Data will be coming through TDRS East.
And we have IIP vanish. Centaur is now orbital. Main engine performance continues to look very good. Chamber pressures are within parameter. LOX pump discharge and fuel venturi are operating as expected for the set mixture ratio. Three minutes to MECO.
Total burn from liftoff at that point will be 18 minutes, 13 seconds.
Storage bottle pressures are stable at this point in the burn. Bus and battery voltages look good. Controlling right down the middle in terms of attitude. Current altitude is 128 miles, downrange position 2,800 miles. Velocity is 18,951 miles per hour. 2 minutes to MECO. All systems continue to operate well. Range track shows the vehicle making good progress. And Centaur has entered the PU limiting phase. Ensure the set MR is within the expected limits. Chamber pressures continue to be stable. LOX pump discharge, fuel venturi, and turbine inlet temperatures are within parameter for the set mixture ratio, which is very close to nominal. One minute to expected MECO. All Centaur systems continue to look excellent at this point in the burn. And we have MECO. Engine shutdown looks good. 4S settling is in progress. Propellant tanks are being vented as expected. Bus and battery voltage are stable. Helium storage bottle is as well. Centaur has begun the turn to the PTC attitude. Has also begun spinning up to 1.8 degrees per second. This coast period is expected to be just over 82 minutes in duration prior to our second burn, which will be just under a minute in duration.
Right now we're going to look at some of the replays from the different camera angles from the liftoff and from some of the tracking cameras on Cape Canaveral Air Force Station and downrange.
.3 kilometers from the expected orbit. Inclination is 4 balls 3 negative. And all in all, looks to be an excellent orbit.
We're now 36 minutes, 30 seconds into the flight of the Atlas V with TDRS-K, coming up on acquisition through the tracking station at Diego Garcia in the Indian Ocean. The Air This is Atlas Launch Control. 1 hour 32 minutes 10 seconds into the flight of the Atlas V with TDRS-K. The vehicle is now within sight of the tracking station at Guam, and the second burn is coming up very shortly. The Centaur right now is reorienting itself and doing some preparations of this onboard systems for that second burn, which is very brief, only about 1 minute and 59 seconds, after which we will have spacecraft separation. And that occurs at 1 hour 46 minutes 1 second after the liftoff. So at this time, we'll be rejoining Marty Malinowski in the telemetry lab. During the 2-minute engine firing, we'll be getting data from Guam, from Diego Garcia, and from the Indian Ocean TDRS, over the Indian Ocean TDRS-Z. So 3 sources of data coming up to give us data on the burn and spacecraft separation. So right now let's join Marty Malinowski once again in the telemetry lab.
With 5 minutes remaining before MES 2, Centaur continues its turn to MES 2 attitude, continues its PTC roll at plus 1.8 degrees per second. Settling continues in preparation for start. All other systems look good at this time. And Centaur has begun the despin from its PTC roll and will try and optimize telemetry. Four minutes to MECO, or MES.
We're at 1 hour 37 minutes into the mission. The Centaur restart occurs at 1 hour 40 minutes 17 seconds into flight. As we can see, the Centaur is reorienting.
D-spin. It continues its turn to the MES 2 attitude. And Centaur has completed the turn to MES 2 attitude. Two minutes to MES.
MES is main engine start.
Centaur tank pressurization is underway. Signatures look good. One minute to MES. Burn duration expected to be just under 1 minute. Dual branch pressurization is underway. We have pre-start. We have oxidizer pre-start. We have ignition and full thrust on the RL-10. Chamber pressures look to be within band. Centaur PU has been set to nominal mixed ratios. Currently accelerating at 1.3 Gs. PU is now operating fuel rich. Chamber pressures, LOX pump discharge, and fuel venturi are responding as expected. Main engine performance continues to look very good. Seeing some thermal conditioning firings on the RCS, and we have MECO. Engine shutdown looks good. We'll now coast for 286 seconds prior to spacecraft set. Fuel tank pressures are venting down. Storage bottle pressures are stable. Bus and battery voltages look good. Centaur has begun reorienting to spacecraft separation attitude. Centaur RCS is now settling at a 50% duty cycle. Fuel tank pressures are venting as expected. Quick check of the orbit show the apogee height to be 2.3 kilometers above nominal. Inclination is minus 4'7". Centaur has completed the turn to spacecraft separation attitude. Continuing to settle at a 50% duty cycle. And Centaur has begun its spin up. Centaur will spin up to 30 degrees per second prior to spacecraft set. Currently spinning at 3 degrees per second. Ten degrees per second. $15 degrees per second. $20 degrees per second. $25 degrees per second. $30 degrees per second, and we have spacecraft separation. Centaur has begun to despin. It will continue to do so and increase settling as it continues on to its collision avoidance maneuver. With that, this concludes tonight's broadcast of the TDRS-K AV-36 mission.
And in just a moment, we'll have our launch director from tonight's flight, Tim Dunn, come over and discuss how the countdown and the launch has gone based on the data that we've received here at the Atlas Space Flight Operations Center. The final burn of the Centaur, lasting just under a minute, appears to have been quite nominal. And so it appears as well that we've had a very successful flight of this particular Atlas Centaur rocket. So that this will set the stage for our next Atlas for NASA, which will be coming up very shortly, in about a week's time. Or slightly more than that, slightly less than 2 weeks. And we'll let Tim tell us about that one. Lots of handshakes from the United Launch Alliance team, as well as the NASA team from the Goddard Space Flight Center, from Boeing, and from the Launch Services Program based here at Kennedy. And they're beginning to configure at White Sands to receive the initial data from TDRS. The first data from the satellite on its own will come through the Dangara tracking station in Western Australia. This is Atlas Launch Control, 1 hour 50 minutes into the flight of the TDRS-K satellite. And joining us here at the console in the Atlas Space Flight Operations Center is Tim Dunn, our NASA Launch Director for tonight's flight. And Tim, first of all, on the surface of it, it looks like we have a happy satellite in orbit.
George, thank you for having me. Yes, indeed, we have a successful spacecraft separation. We just confirmed that via telemetry. So you might have overheard the LCC reacting and the Mission Director Center. There's a lot of happy folks out there, and we've got a customer that's quite thrilled right now to have a healthy satellite on orbit.
Take us through the countdown a little bit from when we first picked up with our coverage tonight, and some of the things that we worked through to get us to a successful launch tonight.
Okay, be glad to, George. We picked up the count on time this afternoon. We obviously knew we had some weather concerns that I'll go into a little bit. Coming into the count, we had a nice clean rocket. Range was very clean as well. And spacecraft, we were working no issues. So when we were coming down through the count, getting ready for cryo-tanking decision, the primary concern we had was with weather. Fortunately for us, the predicted weather that we thought we were going to be dealing with was an encroaching thunderstorm activity and a potential for a Phase 2 lightning advisory, which would have had an impact on tonight's launch attempt. That front stayed well to the north, didn't have to deal with that, but in its place we had ground winds that were right on the borderline of acceptability from a structural concern for cryo-tanking of the Centaur. So we spent a little bit of time. We needed about an extra 10 minutes prior to our nominal, compared to our nominal polling time. I asked Launch Director for that. Our team was able to then analyze the additional data that came in. Simultaneously with that, we worked a launch vehicle issue on the Atlas V. Turned out there was a has-gas sensor, one of a few in the interstage assembly, that had failed. So we had an anomaly discussion. We were concerned about the structural impact of ground winds that were borderline. And that's why we needed just a little bit of extra time prior to going into cryogenic tanking before we were able to complete our poll. Once we worked through that, we got into a nominal timeline. We were headed toward T0 at the front end of the window. We worked just a couple of minor launch vehicle issues during cryotanking. We had a first stage booster liquid oxygen fill and drain valve that did not give us the appropriate talkback signal, but we have a contingency plan where we're able to use pressure data to tell if that fill and drain valve is opening and closing and cycling as planned. So we were able to work through that. A little bit later in the count, we had another sensor on the vehicle. Fortunately, it was triply redundant. It was a pressure sensor that had given us a little bit of noisy data, so we worked through that as well. During that whole time, spacecraft, the TDRS-K spacecraft, was being turned on, rock solid, no problems at all. On the range side, the range had just a few minor issues that they were working. One of the camera sites temporarily went down, came back operational. One of the winds, Doppler radar profilers, went down, went non-mission capable, but the range addressed that quickly and was able to bring that back online. And then one of their upper level winds displays was non-operational. We had redundant capability there, but again, the range team, being a great team that they are, was able to bring that component back as well. So once we got down within a half hour of launch, we were clean and green. Everything looked great, and we went right on the first opening of the window at 8:48 p.m. Eastern Time, and very thrilled with that.
Well, Tim, this is a very short turnaround for United Launch Alliance to get to this point, and it's pretty short to the next one, isn't it?
Yes, it's quite short. It's going to be a quick turnaround for our team. We're going to get a little bit of rest tonight, come back in, start reviewing the data from this mission, the TDRS-K mission, and then get most of our team deployed out to Vandenberg Air Force Base in California for the LDCM mission, the Landsat Data Continuity Mission, which is currently scheduled on Atlas V from Vandenberg on the 11th of February.
Well, Tim, it's been a very intense month here, and with the LDCM coming up as well, I think we can say we've had a very successful Atlas launch campaign here in the last month or so, leading through this flight all the way up to LDCM, and I think the team, I'm sure you think, must feel they've done a very admirable job to get us through these two launches this close together.
Boy, yeah, I'm just thrilled with our team, George. We have just an incredibly competent team, just exceptional dedication that they have. Both the NASA government team working alongside our colleagues at United Launch Alliance, we just have one of the finest launch teams assembled, and I couldn't be more proud of them. So George, on a personal note, I would like to make a comment about this launch. I would like to, as launch director for TDRS-K, I'd like to make a personal dedication of this launch to a special little girl, Delaney Graylick. She's a little 14-year-old girl. She's battling cystic fibrosis. She's over in Orlando at Arnold Palmer Hospital. And I just wanted to say, Delaney, this launch was for you. So we're really thinking about you and praying for you.
Well, Tim, thanks very much, and we'll look forward to seeing you and Omar Baez as well out at Vandenberg, and we're all on a plane out of here very shortly.
Very shortly. So, looking forward to it, George.
And that will conclude our coverage of tonight's Atlas V launch with the TDRS-K Tracking and Data Relay Satellite. From the Atlas Space Flight Operations Center at Cape Canaveral Air Force Station, this is Atlas Launch Control. 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. And liftoff of the Atlas V rocket with TDRS-K broadening, enhancing, and improving the capability of space-based tracking.
Roll program has begun. Body rates look good. Bus and battery voltages are stable. Booster engine continues to operate well. Pump speeds are within parameters. Boost pump pressures are good.